All right, let's just dive right into it. Today, we're demystifying those crucial architectural decisions that truly make the difference between a beautifully stable application and, well, a complete, unmaintainable mess. We're going to be exploring the 7 pillars of app architecture, which is essentially a practical guide that bridges the gap between high-level theory and actual day-to-day mobile and desktop development.
It's a question, literally, every tech lead, senior developer, or honestly anyone who writes code is going to face eventually. Why do some apps scale so effortlessly while others absolutely collapse under their own weight? And spoiler alert here, the answer has absolutely nothing to do with choosing the most trendy framework of the month. It is entirely about how you build your foundational blueprint right from day one.
So here is how we're going to build out that blueprint today. We'll start with the architectural foundation, move into separating and modularizing code, tackle abstraction and testability, scale things up with performance, map it all to real-world architectures, and finally, look at some common mistakes to avoid.
Section 1. The architectural foundation. Let's build that base. Look, architecture influences way more than just how tidy your code looks in a Git repository, right? It's not merely about folder structures or file naming. Your architecture literally dictates your app's performance, its testability, your team's development speed, and, maybe most importantly, how safely you can introduce new features over time without breaking everything else. These 7 core pillars we're going over provide a framework that applies equally to mobile apps, heavy desktop software, and even firmware-inspired environments. Think of it as your ultimate insurance policy.
Moving on to Section 2, separating and modularizing code, basically dividing to conquer. These first 2 pillars, they are the absolute bedrock of any good code base. It starts with Pillar 1, separation of concerns, or SOC. This means dividing the application into distinct sections where each part has a single, well-defined responsibility. The golden rule here is that your UI handles only what the user actually sees. Your business logic makes the decisions, and the data layer handles storage. Never ever mix them. It's kind of like a commercial kitchen. You keep the raw ingredients totally separate from the plating station.
To put that into perspective, take a look at the bad design on the left. It tightly couples the UI directly to the hardware. A button gets pressed, and boom, it immediately commands a write to flash memory. That is a nightmare to debug and practically impossible to test cleanly. But compare that to the much better design on the right. It cleanly delegates the task. The button just says, hey, I was pressed, and an application service actually decides what that means for the hardware. This drastically reduces coupling.
And that naturally leads us to Pillar 2, modularity. This is taking separation of concerns and scaling it all the way up to your project structure. You're structuring your application into independent, interchangeable components, like entirely separate UI, domain, and data modules. By modularizing like this, you ensure that multiple teams can actually work in parallel. Someone can fix the data access module without ever worrying about breaking the UI.
All right, Section 3, abstraction and testability. This is all about future-proofing your logic.
Here's the thing, you literally cannot have true testability without mastering Pillar 3 first. Abstraction and dependency management. The rule here is simple but crucial. Your high-level business logic should never depend on low-level implementation details. Your core rules shouldn't care if data is being saved to a local flash drive, a standard SQL database, or some cloud server. They just need a reliable, predictable interface to talk to.
You can really see the difference when you compare a hard-coded setup versus an abstracted one. On the left, a save function is tied directly to a specific flash memory call. If you change your hardware or switch to the cloud later, you have to rewrite your core logic. Actually, scratch that. You really don't want to do that. Instead, swapping that direct flash write for a storage interface lets you inject dependencies. You can swap storage methods effortlessly without ever touching your high-level logic.
Which directly unlocks Pillar 4, testability. Good architecture makes testing straightforward, not a painful chore. Because we used abstraction in Pillar 3, we can now pass mock or fake implementations right into our logic. Instead of calling physical hardware directly, we call an abstraction. This means we can unit test everything right on our development machines without needing the physical sensors or the actual database connected.
So why should we care so much about this? Well, testability prevents regressions. You know, those incredibly annoying bugs that pop back up after you swore you just fixed them. When your system is truly testable, you unlock the ability to use continuous integration safely, meaning you can deploy new features with total, absolute confidence that you haven't broken the old ones.
Section 4, scaling and performance, handling growth and resources.
As your application matures, it's inevitably going to get heavier. That brings us to Pillar 5, scalability and evolvability.
Now, scalability isn't just about throwing more users at a server. It's about handling more complexity within the app itself. Your architecture has to allow you to add new platforms and extend functionality safely. By utilizing techniques like event-driven systems, like pushing an event to a queue, rather than having two modules tightly call each other, you prevent your whole architecture from collapsing as the codebase grows.
This takes us directly into Pillar 6, Performance and Resource Management. Never, ever block your UI thread. Notice on the left, there's a block and call on the UI thread used to read a massive file. That is a guaranteed way to freeze your app and ruin the user experience. You must always manage heavy tasks in the background using worker threads to ensure the app stays responsive. This is especially critical if you are working in environments where CPU cycles, memory, and battery life are strictly limited.
And rounding out our core principles is Pillar 7, maintainability and readability. Here is the hard truth about software development. Code is maintained far, far longer than it is originally written. You have to document your intent through clear structure and consistent naming. Naming a variable sensor_temperature_Celsius instead of just the letter F might seem like a small, almost pedantic detail at the time, but it drastically lowers bug rates and massively speeds up how fast new developers can get onboarded.
Section 5. Mapping to Real Architectures. Time for the big reveal.
Now you might be listening to this and thinking, hey, I already do some of this, and you probably are. Let's map these pillars to the patterns you likely use every day. If you look at MVC, it gives you separation of concerns and maintainability. MVVM does a great job hitting separation of concerns, testability, and modularity. But the real standout here is clean architecture, which is explicitly designed to enforce all 7 pillars simultaneously. By understanding these underlying pillars, you aren't just blindly memorizing an acronym, you actually understand why the pattern was designed that way in the first place.
Finally, Section 6. Common mistakes to avoid. The pitfalls. Look, even the most senior developers can fall into architectural traps if they stray from these principles. Watch out for these 5 common missteps. We've talked about mixing UI and business logic, hard-coding dependencies, and ignoring testability. But points 4 and 5 are where a lot of modern projects just totally fail. There's a huge temptation to over-engineer your system too early, building these complex abstractions you don't actually need yet. Conversely, waiting until the very end of the project to think about memory usage and performance, that usually leads to massive architectural rewrites right before launch.
Here is a final, super practical example of avoiding these mistakes. If you ever catch yourself tightly coupling a dependency, like hard-coding a UART send function right inside your data processor on the left, just stop. Remember to inject a notification interface instead. It keeps your entire system completely decoupled, incredibly flexible, testable, and strictly adhering to our pillars.
We're going to end on this thought right here. Strong application architecture is not about choosing a trendy pattern. It is about consistently applying a set of principles. These 7 pillars provide a framework to guide your decisions no matter what you're building. So ask yourself, as you look at your own codebase today, are you just blindly following whatever framework is trending, or are you actually building an adaptable, resilient blueprint by applying these 7 timeless principles? Keep these pillars in mind, and I promise your applications will become significantly easier to manage over time. Thanks for joining me for this explainer.